Hi, this is an update on my previous video on a battery fuel gauge for my Macqueen Robot. But this time I'm going to use the M5StickC, and I think I've found the best host for the fuel gauge. So let's have a look. So here are some of the desktop photos of how the battery and the fuel gauge and the M5StickC are all connected. And I'll quickly just go through the project and show you the results. So just recapping, this is all based on the MAX 17043, which has an algorithm built in to measure the remaining charge left on a lithium-ion battery. All I have to do is add the computer. And there are two connections, one for interrupt and the other one for the I2C bus. The interrupt is stripped when the low battery threshold level is low, and the microcomputer can do something about that. So the objectives I've got here are to port the DFRobot software, which is in Arduino format or C++ format, to the M5StickC Plus. And this computer is an ESP32 based computer. So why not use some of the extra facilities that it has? So I'm going to show the remaining fuel on the M5StickC Plus LCD screen, both with text and with graphics. And I'm also going to show a line where the low fuel threshold level is. I'll include an interrupt and interrupt processing for low fuel levels. And I'll show that on the screen with a red line. So here's the hardware, just like before. We've got the Gravity I2C 3.7 volt lithium battery fuel gauge. We've got cables, both the DFRobot and also a Grove cable. We've got a lithium battery, and I'm using the Make Block battery. And finally, from M5Stack, I'm using the M5StickC Plus with its screen, and I'll be utilizing that. So just recapping, we've got the Gravity battery fuel gauge, and that connects to a lithium-ion battery. And in this case, it goes via the I2C port onto the Grove connection on the M5StickC Plus. So on the M5StickC Plus, we not only have the I2C connection, but we've also got the warning from the fuel gauge indicator, and that's the one that gives us the interrupt. And we can pass on a warning to the Macqueen Plus Robot. And of course, we have to have power from the robot. And the software, similar to the previous software, but this time I'm adding an additional library, and the library is from the M5StickC Plus. And it's mainly about drawing onto the screen. So I'm drawing objects, lines, rectangles, filling the rectangles, and that'll be needed to show the level of fuel remaining. I want to set the cursor because I'm adding a bit of text, and I want to update the text at the same position on the screen. It's got to be readable too, so I need to set the font size, which I haven't actually showed, but that's an additional API. And also, the graphics are permanent, so you have to actually erase the whole screen if you want to update even just one character. So I go through a routine which clears the screen by filling it with a black color. And here's the main loop. I won't go through all the software. The first part is similar to what it was before. And in this loop, you can see that I'm printing out to the serial port the data, both the voltage of the battery and also the percentage of charge remaining. Then I prepare for updating the M5StickC LCD. And you can see that I'm painting the screen black, putting in a message of how much fuel's left. Then, depending on how much fuel is left, if it's less than the threshold, I fill up the rectangle with red, or if there is enough fuel, that is, it's above the threshold, it's filled with blue. And I also put in a line in red at that threshold level. And you can see that how I'm processing the interrupt. And the results, it all worked. So I get not only a message on the computer for the values over the USB serial comms, but it also gives me a nice graphical display on the M5StickC Plus LCD. And this is what it will look like when it is mated to Macqueen Plus. It won't only just give me this capability, but Macqueen Plus now has a LCD. So all I need to do is improve the communications, and I'll also use the I2C connection between the two processors. And the M5StickC has got hosts of other things on board. It's got sensors, a Hall sensor for magnetic detection, but it also has an IMU, and perhaps I can use that in some of Macqueen Plus, their processing. And the M5StickC has both Wi-Fi and Bluetooth, and I'm sure that'll come in handy for Macqueen Plus communications. Well, here, that's all for the time being, but here are my references, both to DFRobot and also to M5Stack, which is where I got the M5StickC Plus little computer. This is my latest version of the battery fuel gauge. And what I have on the left here is a lithium battery. And next to that is the DFRobot lithium battery fuel gauge. And it feeds a signal via the cable here into the Grove port, which is a I2C connection, onto a M5Stack computer. And the computer is a M5StickC Plus. And it shows on the screen the amount of fuel left, or the amount of charge in the battery, and the threshold. So the red line is the threshold. Below that, the screen, the graph goes red instead of blue. And I've programmed all this on a Arduino IDE. And there's not only just a I2C connection, but there's also an interrupt connection. So the alarm threshold is set and programmed by the M5StickC Plus, and if the charge is less than the threshold, an interrupt is generated on GPIO 19 on the M5StickC. And so that's going to go into the DFRobot Macqueen Plus for its fuel management.